Dear students, I am Professor V.R. Shilwant, Electrical and Electronics Engineering Department, SDM College of Engineering and Technology, Dharwad, Karnataka. In this video lecture, I am going to take up construction of synchronous generator or alternator. The main parts of synchronous generator are stator and rotor. Depending on the type of construction, the rotors are classified as a salient pole rotor and a cylindrical rotor. A stator is a stationary part. It is having a stator core. A stator core is a hollow cylinder with slots cut on its inner periphery. In these slots on the inner periphery, the three-phase winding is placed. The three-phase winding may be connected in star or in delta. The stator core is made up of silicon steel laminations in order to reduce hysteresis and eddy current losses. The entire core along with the winding is placed inside the yoke. Yoke is outermost part of synchronous generator. It is a hollow cylinder made up of mild steel or cast iron. It gives protection to the motor against the atmosphere and mechanical injuries. In salient pole rotor, there is a rotor core at the center through which a shaft passes. From this rotor core, the poles are projected outward. On the longer part of the pole, called as pole core, the field winding is placed. When the current through this field winding passes, then the poles become electromagnet. By controlling the current through the field winding, the magnetic field strength can be controlled, and hence the EMF induced in the alternator can also be controlled. At the outer end, the poles are widened. These widened regions are called as the pole shoes. In the pole shoes, some slots are cut, and in these slots, the conductors are placed. These conductors are short-circuited on either side. These rotor conductors which are short-circuited on either side are called as the damper windings. Damper windings are helpful in overcoming the oscillations of the rotor when the load changes drastically. In cylindrical rotor, the rotor is cylindrical in shape and it is made up of silicon steel laminations. On the outer periphery of the rotor core, the slots are cut on either side of the poles. In these slots, the field windings are placed. When DC current flows through the field winding, the poles become electromagnets. It is to be remembered that alternators using salient pole rotors produce lot of noise, whereas the alternators using cylindrical rotors do not produce much noise. In both the types of rotors, field windings are supplied with slip ring and carbon brush arrangement. The salient pole rotors are used in low-speed applications like hydroelectric power plant, whereas the cylindrical rotor alternators are used in high-speed applications like thermal power plants or gas-operated power plant. In next video, I will be taking up derivation for EMF equation of an alternator.